Hello friends, welcome to our channel Piping Mantra.
Hello friends, today we are going to learn about different types of valves used in piping industry. This video is continuation to part 1, so if you have not watched part 1, please watch it from here or we have link in description. As we have mentioned in part 1 that this video is a part of our piping engineering course. So in this video we are going to learn about different types of valves, so let's get started. First is ball valve. As we have seen, a ball valve is a quarter turn rotary motion valve that uses a ball shaped disc to stop or start the flow. When a port in the ball is in line, it allows flow, whereas when you rotate the valve 90 degrees, solid part of the ball stops the flow. Let's have a look at valve parts. Major components of the valve are the body, spherical ball, steam, and seats. It can be metal seated or soft seated. The valve may be unidirectional, bidirectional, or multidirectional, depending on the number of valve ports and the number of valve seats. In the image, you can see a three-way ball valve. Depending on the requirement, you can arrange the port of the valve in the three-way. One inlet and two distribute, one inlet and one outlet with diverting a flow, straight pass the fluid without no inlet. Three-piece ball valves are available up to 1.5 inches and two-piece ball valves are available above 2 inches. There are three types of ball valves available, that is Venturi port type, reduced port type, and full port type. The full port ball valve has an inside diameter equal to the inside diameter of the pipe. This design allows pigging. In the Venturi and reduced port types, the port is generally one pipe size smaller than the line size. For applications of the valve, it can be used in different types of fluid services as an on-off stop valve that provides bubble-tight shutoff. It can be used in air, gaseous, and vapor services as well as hydrocarbon services. Drains and vents in liquids, gaseous, and other fluid services. Metal-seated valves can be used in high pressure and temperature applications. It is widely used with instrument tubing to connect instruments. Now let's talk about advantages and disadvantages of valve. Let's talk advantages first. It is quick to open and close, providing bubble-tight reliable sealing in high pressure temperature applications. It is smaller and lighter than a gate valve of the same size and rating. Several designs of ball valve offer the flexibility of selection so that you can choose the valve that suits your requirement. It is easy to operate and cost-effective maintenance. For disadvantages, it cannot be used in services that require throttling. In slurry or other similar applications, the suspended particles can settle and become trapped in body cavities, causing wear, leakage, or valve failure. Due to rapid opening and closing, surge pressures may arise which could damage downstream equipment, and it is expensive. Next valve is butterfly valve. A butterfly valve is a quarter turn rotary motion valve that is used to stop, regulate, and start the flow. Butterfly valves are easy and fast to open. A 90-degree rotation of the handle can completely close or open the valve. Normally, they are used in systems where positive shutoff is not required. Large butterfly valves are usually equipped with gearbox type actuators. Based on the type of ends of the body, butterfly valves are available in following types. Wafer butterfly valve. The wafer body is placed between pipe flanges and the flange bolts surround the valve body. A wafer type butterfly valve is easy to install but it cannot be used as an isolation valve. Lug style butterfly valve. The lug body has protruding lugs in the periphery of the body that provides passage to bolt holes that match with those in the flanges. Flange butterfly valves. In this type, the body has flanges that match with pipe flange dimension. Butt welded ends. This type of ends are used in high pressure services and is directly welded to the pipe. Now let's talk about seat types. Butterfly valves can be metal to metal seated, soft seated, or with a full lined body and disc. The first image is of soft seated fully lined body and disc valve. Second is a soft seat with metal disc. The third is metal to metal seat type valve. The disc of butterfly valve can be concentric or eccentric with the valve body. For applications of butterfly valves, a butterfly valve is used in many different fluid services and they perform well in slurry applications also. They can be used in liquids, steam, cryogenics, cooling water, air, gases, firefighting, and vacuum services. Butterfly valves is used in all types of industrial application, even in high pressure and temperature services. Let's talk about advantages of butterfly valves. Butterfly valves is suitable for large valve applications due to compact, lightweight design that requires considerably less space as compared to other valves. Due to a quick operation, it needs less time to open or close. The maintenance costs are usually low compared to other valve types. A pressure drop across the butterfly valve is small. Valve with non-metallic seating can be used in chemical or corrosive media. Let's discuss the disadvantages now. Throttling is limited to low differential pressure surfaces and that too with a 30 to 80 degree disc opening. There is a chance for cavitation and choke as the disc is always in the turbulent flow affecting the disc movement. Next valve is globe valve. A globe valve is a linear motion valve used to stop, start and regulate the fluid flow. The globe valve disc can be removed entirely from the flow path or it can completely close the flow path. The seat opening varies in direct proportion to the travel of the disc. During the opening and closing of the valve, the disc moves perpendicularly to the seat. This movement creates the annular space between the disc and seat ring that gradually closes as the valve closed. This characteristic provides the globe valve good throttling ability required for regulating the flow. I hope so far you would have liked this video. You can enroll to our piping engineering course. Course link is in the description box and in the comment section. Leakage from the globe valve seat is less as compared to the gate valve, mainly due to the right angle contact between disc and seat ring. Here in the image, you can see various globe valve parts such as body, bonnet, stem, seat, disc, etc. Depending on the design or body pattern of globe valve, there are three types of globe valves. Standard pattern, also known as T pattern or Z pattern, oblique pattern, also known as Y pattern, and angle pattern. Globe valves are used in the systems where flow control is required and leak tightness is also important. It is used in high point vents and low point drains when leak tightness and safety are major concerns. Otherwise, you can use a gate valve for drain and vent. It can be used in feed water, chemical, air, lube oil, and almost all services where pressure drop is not an issue. This valve is also used as an automatic control valve, but in that case, the stem of the valve is a smooth stem rather than the threaded and is opened and closed by lifting action of an actuator assembly. Let's talk about advantages of globe valves now. Better shut off as compared to gate valve, moderate to good throttling capability, good for frequent operation as no fear of wear of seat and disc. Easy to repair as seat and disc can be assessed from valve top. Fast operation compared to gate valve due to shorter stroke length. Available in many patterns, each offering unique capabilities. Usually operated by an automatic actuator. Have a look at some disadvantages now. High head loss from two or more right angle turns of flowing fluid within the valve body. Obstructions and discontinuities in the flow path lead to a high head loss. In a large high pressure line, pulsations and impacts can damage internal trim parts. A large valve requires considerable power to open and create noise while in operation. It is heavier than other valves of the same pressure rating. It is costlier compared to the gate valve. Next is gate valve, which is also a linear motion valve. A gate valve can start or stop the fluid flow by using a gate or wedge type disc and the disc moves perpendicular to fluid flow in piping. Gate valves should not be used for regulation or throttling of flow because accurate control is not possible. The high velocity of the flow in the partially open valve may cause erosion of the disc and seating surfaces and also creates vibration and noise. The larger sizes have been supplemented by butterfly valves due to space limitations under which they are installed. Here you can see the main parts of the gate valve. The disc of the gate valve is also known as a wedge. There are three ways to classify the gate valve. First, according to type of disc, parallel gate valves. It uses a flat gate between two parallel seats, like conventional parallel gate, through conduit gate, and knife gate. Based on type of body bonnet joint, screwed bonnet, bolted bonnet, welded bonnet, and pressure seal bonnet. Based on the type of stem movements, there are two types, rising stem and non-rising stem. Rising stem is further classified into outside stem and screw type and inside stem screw. For a rising stem valve, the stem will go up while opening the valve and move down when you close the valve, also known as OSNY valve. OSNY means outside steam and yoke. In outside steam screw configuration, the external side of the stem is threaded while the part of the stem which is inside the valve is plain. There is no upward movement of the stem in a non-rising stem type. The valve disc is threaded internally. The disc travels along the stem like a nut when the stem is rotated. In inside stem screw configuration, the threaded part of the stem is positioned inside the valve body, whereas the stem packing lays outside. Next is wedge gate valves. It uses slightly mismatched inclined gates between inclined seats. The types are solid taper wedge, split wedge, and flexible wedge. For gate valve applications, gate valves are used in almost all fluid services such as air, fuel gas, feed water, steam, lube oil, hydrocarbon, almost any services in almost all the industries like refineries, petrochemical and gas processing plants, etc. Some special gate valve is also used in slurry and powder products such as knife gate valve. Let's have a look at advantages of gate valve now. Gate valves provide good on-off-off shut-off features. Pressure drop during operation is very less. Most of the gate valves can be used as bidirectional. They are suitable for high pressure and temperature applications and require less maintenance. Gate valves tend to be slightly cheaper than ball valves of the same size and quality. Next is disadvantages of gate valve. It cannot be used to control the flow. A gate valve is slow in operation. Opening and closing takes time, which is good. Also, it reduces the chance of hammering. When partially open, it creates vibration and noise. Repairs, such as lapping and grinding of seats, are more difficult due to limited access. Gate valves require large space envelope for installation, operation, and maintenance. Some designs of gate valves are susceptible to thermal or pressure locking depending upon the application. Next is check valve or NRV. A check valve is a device that only allows the flow of fluids in one direction. Check valves, also known as non-return valves or NRV, or one-way valves, are automatic valves that normally allows fluid, liquid or gas to flow through it in only one direction. The main purpose of a check valve is to prevent backflow in the system. A check valve relies on a pressure differential to work. They require a high pressure on the input side of the valve than the output side to open the valve. When the pressure is higher on the outlet side or the input side pressure is not high enough, the valve will close. Depending on the valve type, the closure mechanism is different. Unlike other valves, they do not need a handle, lever, actuator, or human to correctly work. But how does a check valve work? This minimum upstream pressure at which the valve opening occurs is called the check valve cracking pressure. If the upstream pressure ever falls below the cracking pressure or there is a back pressure, that is flow attempting to move from the outlet to the inlet, then the valve will close. Installation orientation. As a one-way valve only works in one direction, it is crucial to know the correct installation orientation. Oftentimes, there is an arrow on the valve housing to signal the flow direction. Otherwise, you'll need to examine the valve to ensure it is installed in the intended flow direction. If it is backwards, flow will not be able to move through the system and a buildup of pressure could cause damage. We must make sure that the particular check valve type will work in the said installed position. For example, not all check valves will work in a vertical line with fluid flowing downwards. Not all conventional or 90-degree piston check valves perform in a vertical line without a spring to push the disc back into the flow path. The disc in some check valves extend to the pipeline when the valves are fully open. This could interfere with the performance of another valve bolted directly to the check valve open. Check valves may be grouped according to the way the closure members move onto the seat. Few basic and most used types of check valves are listed and detailed out here. First is swing check valve. The closure member swings about a hinge which is mounted outside the seat. Next is the dual disc valve. The dual disc valve is designed to provide flow in one direction and close rapidly when backflow occurs. Dual disc responds automatically to block flowing fluid in one direction and prevents reverse flow. Piston or lift check valves. The closure member travels in the direction normal to the plane of the seat. This is vertical lift check valve. Ball check valve. The closure member consists of a ball which travels in the direction normal to the plane of the seat and rotates constantly. Tilting disc check valve. The closure member tilts about a hinge which is mounted near but above the center of the seat. Diaphragm check valve. The closure member consists of a diaphragm which deflects from and against the seat. Stop check valve. It is a combination of a lift check valve and a globe valve. It can either be used as a check valve or as an isolation or stop valve like a globe valve. Spring-loaded check valve. The closure member consists of a standard-guided stem disc assembly along with the compression spring. Next is duckbill check valve. The closure member consists of a soft tube of which the end has a natural flattened shape. Check valves are used in the case of pumps and compressors where backflow could damage the internals of the equipment and cause an unnecessary shutdown of the system. Centrifugal pumps, the most common type of water pumps, are not self-priming and therefore check valves are essential for keeping water in the pipes. Check valves may also be used in lines feeding a secondary system in which the pressure can rise above that of the primary system. This pressure difference may cause reverse flow. Check valves are often used when multiple gases or fluids are mixed into one stream. A check valve is installed on each of the individual fluid streams to prevent mixing of the fluid in the original source causing contamination. Other than with steam traps discharging to atmosphere, check valves should always be inserted after a steam trap to prevent backflow of condensate flooding the steam piping. There is no such comparison on check valves since its only function is to prevent backflow and there is no other alternative. However, you can select best type of check valve based on the requirement. Next is plug valve. A plug valve is a quarter turn rotational motion valve that uses a tapered or cylindrical plug to stop or start flow. In the open position, the plug passage is in one line with the inlet and outlet ports of the valve body. If the plug is rotated by 90 degrees from the open position, the solid part of the plug blocks the port and stops flow. Plug valve is similar to a ball valve in operation. The face-to-face standard for plug valves is normally associated with NC standard B16.10. However, many manufacturers have elected to use face-to-face dimensions provided for gate valve, so that plug valves can be used as a replacement for gate valves in existing process services. Now let's talk about plug valve parts, in which first is plug valve discs. Plugs are either round or taper cylinder. They may have various types of port openings, each with a varying degree of the opening area, like rectangular port, diamond port, and round port. Rectangular port is the most common for plug valve. The rectangular port represents at least 70% of the corresponding pipe's cross-sectional area. Round port plug has a round opening through the plug. It is available in full bore and reduced bore designs. Valves with reduced ports are used only where restriction of flow is not important. Diamond port plug has a diamond-shaped port through the plug. All diamond ports valves are Venturi restricted flow type. This design is for throttling services. Plug valves are used as on-off stop valves and capable of providing bubble-tight shutoff. It can be used in different types of fluid services such as air, gases, vapor, hydrocarbons, slurries, mud, and sewage applications. Plug valves are commonly used in low pressure, low temperature services, although some high pressure, high temperature designs also exists. Plug valves are high capacity valves that can be used for directional flow control even in moderate vacuum systems. Plug valves can efficiently handle gas and liquid fuel. Let's discuss advantages of plug valves now. Simple design with few parts. Quick to open or close. Maintenance and repair of plug valves can be done at the place of operation. Offers minimal resistance to flow. Provides reliable leak-tight service. Multiple port designs help reduce the number of valves needed and permits a change in flow direction. Smaller in size than most other valves. Let's have a look at disadvantages once. It requires greater force to open and close due to high friction. 100 NB and larger valve sizes cannot be operated manually and require an actuator. Pressure drop due to reducing port caused by tapering of plugs. Cost of plug valves may be more than ball valves for given size and class. Next is needle valve. A needle valve, also known as plunger valve, is a valve that is used where continuous throttling of flow is required for regulation. Needle valves are similar to the globe valve in design, with the biggest difference is the sharp needle like a disc. Needle valves are designed to give very accurate control of flow in small diameter piping systems. Needle valves have a small port and a threaded needle-shaped plunger. This arrangement permits a very gradual increase or decrease in the size of the opening, allowing precise regulation of flow, although it is generally only capable of relatively low flow rates. Needle valves can operate manually or automatically. Needle valves consist of valve housing, taper point, end plunger, and bonnet. Needle valves are frequently used as metering valves. All field analog instruments are fitted with a needle valve to control flow entry, where sudden surges of fluid under pressure can damage the instruments. Needle valves are used in low pressure hydraulic systems, chemical processing, and other gases and liquid services. Needle valves are used in flow metering applications, especially when a constant, calibrated, low flow rate must be maintained for some time. Since flow rates are low and many turns of the valve stem are required to completely open or close, needle valves are not used for simple shut-off applications. Small, simple needle valves are often used as bleed valves in water heating applications. One of the most commonly used location for needle valves is to monitor gas flow like propane in a system. Needle valves are also sometimes used in vacuum systems in order to release a controlled yet steady supply of gas without a great amount of pressure. Let's talk about advantages of needle valve first. The flow control at a low rate is very accurate. Needle valves are smaller in size. They can be used for throttling purpose. Flow rates can be adjusted accurately. Needle valves are used as bleed valves for hot water heating. These valves can shut off easily. Now let's talk about a few disadvantages. Pressure loss is high in needle valves because of the high restriction of the fluid flow. This valve is used for low flow rates because of the small passage flow between the seat and needle. Damage could happen to the seat and the needle if the fluid has suspended solids. We won't be able to tell if the valve is open or closed by examining the handle position. And lastly, because of the excessive turning force while shutting off, the seat of the needle valve could be damaged. Next is pressure relief valves or PRV. A pressure relief valve is a safety device designed to protect a pressurized vessel or system during an overpressure event. An overpressure event refers to any condition which would cause pressure in a vessel or system to increase beyond the specified design pressure or maximum allowable working pressure, MAWP. The primary purpose of a pressure relief valve is protection of life and property by opening and relieving excess pressure from overpressure vessels or equipments and to reclose after normal conditions have been restored. Many electronic, pneumatic, and hydraulic systems exist today to control fluid system variables such as pressure, temperature, and flow. Each of these systems require a power source of some type such as electricity or compressed air in order to operate. A pressure relief valve must be capable of operating at all times, especially during a period of power failure when the system controls are non-functional. The sole source of power for the pressure relief valve, therefore, is the process fluid. It is important to ensure that the pressure safety valve is capable to operate at all times and under all circumstances. The safety valve is not a process valve or pressure regulator and should not be misused as such. Difference between pressure safety valve and pressure relief valve. Pressure safety valve and pressure relief valves are commonly used terms to identify pressure relief devices on a vessel or equipment. Although freely used interchangeably, these terms differ in the following aspect. Pressure relief valve is the term used to describe relief device on a liquid-filled vessel, whereas pressure safety valve is the term used to describe relief device on a compressible fluid or gas-filled vessel. For pressure relief valves, the opening is proportional to increase in the vessel pressure. Hence, the opening of the valve is not sudden but gradual if the pressure is increased gradually. For pressure safety relief valves, the opening is sudden. When the set pressure of the valve is reached, the valve opens almost fully. Now, let's move on to some special valves. First is diaphragm valve. Diaphragm valves are used whenever either the fluid is highly corrosive or high degree of purity is required in process. For example, pharmaceutical and food processing industry. Next is flush bottom valve, usually a globe type designed to minimize pocketing, primarily for conveniently draining liquid from the low points of a tank. These are special type of valves which are used to drain out the piping, reactors and vessels. These are attached to the vessels on pad type nozzle. The discs in closed position match with the bottom of the vessel or piping, leaving no room for hold up or stagnation. There are two types of flush bottom valves. Valves with disc opening into the tanks and valves with disc into the valve. Now let's see the difference between flush bottom valve and pressure safety valve. The function of flush bottom valve is to isolate or regulate, whereas pressure safety valve is a safety device relieving extra pressure. The manufacturing code followed for flush bottom valve is standard or STD and for pressure safety valve is API 520. The installation location for flush bottom valve is below equipment, whereas pressure safety valves are installed above equipment. The services flush bottom valves are used in are liquids, whereas PSVs are used to relieve gas pressures. The outlet size is one size smaller than inlet for flush bottom valves, whereas the outlet size is one size larger than the inlet in case of pressure safety valves. The PNID symbols for both flush bottom valves and pressure safety valves are shown on your screens. Next is breather valve. The minimum function of a breather valve is to be used on big tanks, to break vacuum at the time of draining or pump out conditions, and to release the air at the time of filling tank. Now let's talk about some other special valves which are not widely used. First is pinch valve. Also known as clamp valves, pinch valves are designed to control or shut off the flow from abrasive, granular, fibrous or corrosive media. Most other valve types are unable to handle fluids with high concentrations of solid due to the particles often jamming the metal parts and clogging up the valve. The pinch valve finds its wide application in such conditions. It is used in pharmaceutical and food industry. There are some disadvantages of pinch valves like temperature range is limited, medium operating pressure is limited, face-to-face length may be an issue when limited space for fitting the valve is available. Next is float valve. The float valve controls the level by opening and closing a valve in response to the changing levels. Same valve you can see in overhead tanks in your houses. Next is foot valve. A foot valve is a non-return valve installed in a pump suction or at the bottom of the pipelines to prevent water from flowing backwards when the pump is off. The valve keeps the fluid trapped in the suction pipe when the pump stops, thus sustaining a suitable prime for the pump and preventing pump burnout. Next is piston valve. A piston valve is a device that is used to control the motion of a fluid along a tube or pipe by means of the linear motion of the piston within a chamber or cylinder. Piston valves are used for fully open or fully closed for on-off regulation on steam, gas, and other fluid services. It is similar to globe valve. Last is ramp valve. The ramp valve is a multi-purpose, tightly sealing shut-off device for bulk solids or slurries. Its unique performance achieved by better sealing arrangement caused by wedging action of the ramp bar between the top surface of the slide plate and the inner throat. Personally, I have not used that valve so far in my career.
So that is it guys for today's video. We love reading your comment and suggestions, so please comment below. We do read every single one of your comment. If you like this video, please hit the like button and share with your friends and colleagues who may find it useful. If you have any time, please check out our other videos over there.